All right, we are live. So, hello and welcome everybody to the SHSAT math practice test live stream. I had a request from one of my subscribers to do an SHSAT practice test for the math section, and the rules are or anyone, you cannot use a calculator for this, and you don't get any formulas for this. There might be some more rules here, but um, I'm just going to jump right into this. Now, I'm doing these questions cold. I haven't got a good look at the questions ahead of time. The only glance that I got is when I was making this PDF. I extracted it from a much bigger document, just so the program would run smoother. But I'm basically going into these questions cold, and I'm trying to model here like how I would prepare for an exam like this. So, just because I'm a math teacher, I don't um, claim to like, oh, now I only get hundreds on every single math test, whether it's any test from K through 12. That's not the case. If I had to personally take the SHSAT myself, I would sit down with a practice book. I would become familiar with the format of the test, the types of questions that they ask, because the best way to prepare for something is to know what you're going to be walking into. So I'm just going to kind of model that right now. That I'm coming in with an unfair advantage that I've been teaching math for a while. I was a math major, and I'm pretty comfortable with like the majority of the math that I would run into at any level from K through 12. But once again, this test, I'm like not sure what the format is, and I'll just have to kind of like analyze and react to it as I'm going through it. Okay, so that's um, what I'll be doing for this video. So to anyone who just joined, hello and welcome. And to anyone watching the replay, thank you for, checking this out. So let's just get right into it because there's a lot of questions to cover here. I just have to verify here. I want to see how many. Let me actually, before I get rolling here, pull up a document just so I can see how many questions that we are, in fact, going through here. So I will flick that back on in one moment, give people a chance to join up as well. So let me just see, where is the, okay, here's the document. There are, let's see, it goes from 58 to 114. Okay, so from 58 to 114 is how far we're going. Right, so let me just shrink this down now. So get this screen reconfigured, and yeah, we'll get rolling in just a moment. So now I could switch this back on. All right, so 58 to 114. So that's quite a few questions. All right, 58 to 114. Let me just do the math real quick. And then I got to add one, right? The inclusive idea. So this is, let's see, 57 questions. Oof. All right, well, let's just get to it then. Don't waste any time. So 58, we have the figure below shows a circle with a hole in the middle, and the outer diameter is 1 1/4 inches. The diameter of the hole is 1/4 inch. What is the area of the shaded region to the nearest hundredth of a square inch? Okay, so for this one, I would find we're basically going to be doing pi times the big radius squared minus pi times the little radius squared. Okay, so we're doing big circle minus little circle, but they gave us the diameter. So the first thing I would do here is find the big radius, which is half of this. And if I want to cut, that's 1.25. If I want to cut this in half, I just divide this by 2. So this is, let's see, 0. All right, I guess I could just do the long division on the side. Remember, we don't get a calculator here. So 1 1/4, though, there's another way of doing it. If you turn this into a mixed number, that's 5/4. I'm sorry, an improper fraction, that's 5/4. You want to cut something in half, you just double the denominator. So if I did half of like r equals 5/4 times a half, that's 5/8. Okay, so it's 5/8 of an inch, the radius of the, I should call that big R actually. So big R is 5/8. And then little r would be half of 1/4, which is 1/8. Okay, so Anytime you want to divide a fraction by 2, you double the denominator. So just thinking out loud here. So now I just plug in. I have pi times 5/8 squared is 25 over 64 minus pi times little r squared would be 1 over 64. So now this works out to, we're going to have pi times 24 over 64. Okay, so yeah, this one here, we're just combining like terms. So just imagine here you're using the distributive property, but backwards. Like you're saying pi times 25 over 64 minus 1 over 64 like this. And that's where this is coming from. And I would reduce that because if we have to do this without a calculator, and we're rounding to the nearest hundredth, so we actually have to do some like decimal work here. So for this one here, I would divide the top and bottom by 8. Actually, divide by 8, top and bottom. Oh, so at yeah, Fortnite Sweaty Kid, this was all for you. So I'm glad you're here. So this is 3/8 pi. Okay. So if I'm doing this one by hand to get to the nearest hundredth, so I'm running out of space real quick. Pi, I'm going to approximate is 3.14159 and then 26 something, but I could stop here at 3.14159. And 3/8 is 0.375. So I guess I could do a lot of long multiplication here, but I kind of don't want to multiply this many digits out. That's going to take up a ton of space. So we're rounding to the nearest hundredth. So I would say here, if we go to the thousandths place, like that should be enough, because 15926, like I'll just stop it here. I mean, whatever. I guess I got to just do this. So I will. So pi, I'm multiplying by 3 and then dividing by 8. Okay, so times 3. We're going to have 27, carry the 2. 15 plus 2 is 17, carry the 1. 13, carry the 1. And then 3 plus 1 is 4. And then 0.3. I'm sorry, 3 times 3 is 9. What did I just do? Okay, so just making sure this is good. So 7, 2, carry the 1. 7, carry the 1. Wait. Hang on a sec. Let me just go back. All right. 27. Carry the 2. 17. Carry the 1. 3 times 1 is 3 plus 1 is 4. 3 times 4 is 12. Carry the 1. 3 times 1 is 3 plus 1 is 4. And then 3 times 3 is 9. So this would work out to 9.42477. And then we have to divide this by 8. Okay, so this number, let's see, divided by 8. So this will go in once with the remainder 1, once with the remainder 6. That goes in here 7 times, that's 56, remainder 6. So then this goes in 8 times. So here to the nearest hundredth, 1.18, I'm going to go with here. 1.18 is going to be the area of the shaded to the nearest square inch. Okay. Oh, they ask you to do 3.14 for pi. That's very helpful to know, so I don't struggle. But yeah, that's the thing. I should, as I reflect on this and whatnot, when I do stuff like this, learn the rule set. You definitely want to learn the rule set before you just show up to the test. But this is just kind of my first glance at one, and I want to be sure. I didn't want to but yeah. All right. So apparently the rules, thank you, that you can use 3.14. So a homeowner has a budget of $135 for the installation of a light fixture. An electrician charges $60 per hour plus a one-time trip charge of $45. What is the greatest amount of time? So what is the greatest amount of time in hours the electrician could work on the installation while staying within the homeowner's budget? Write your answer as a decimal. So they have a budget of $135 for the installation of a light fixture. They charge $60 per hour plus a one-time trip charge. So first I would take the $135 budget and subtract $45 and $90 left. But they charge $60 per hour. So if we do 90 divided by 60,
That's 1.5. So can work. So in hours, what is the greatest amount of time in hours? Write your answer as a decimal. So 1.5? Yeah. Um, I'm going to try to be flawless here. These first few questions are like not polite though. But whatever, I'm going to grade them at the end. Okay. So if I make a mistake, I'll reflect on it and say, oh, that's what they meant. The list shows the daily low temperatures in a city during 6 days in the winter. Okay, daily low temperatures. What is the difference between the lowest and highest temperatures in degrees Fahrenheit for the 6 days? Okay, so find the smallest number in the list is -5. This is actually the kind of question I probably get wrong because I don't know. It's like I have to find something. It's like a word search, and I'm just like, oh, that's annoying. So what is the difference between the lowest and the highest? Well, 7 minus -5. 12. I believe that's should be pretty straightforward. I'm hoping. I'm always on the lookout too for bear traps. Like there's some questions that they're gonna be like, haha, I got you. But this one here I think is hopefully pretty straightforward. Yeah. 61. Let's zoom in a little bit. That other question was taking up so much space. That first question, so I zoomed out. All right, this should be good enough. A grocery store sells 1-gallon containers of milk for $3.99. The store also sells orange juice in a 6-pack of 5.5 fluid ounce bottles for how much more? Oof. All right. Here we go. So now we got to do some converting here. So a grocery store sells 1-gallon containers of milk. So let me just write this. So milk, we've got 1 gallon is $3.99. Let's do this. All right. Orange juice, and I'll write in orange. So orange juice, they're doing 6-packs. So a 6-pack of 5.5 fluid ounces. And this is $1.79. Okay. Suppose the store wants to sell its orange juice in gallon containers instead. So here we go. We got to turn this, build up a gallon with this. So to the nearest dollar, how much more would a gallon of orange juice cost than a gallon of milk? Okay. So here, I want to say the idea is, I guess it doesn't matter that it's a 6-pack. What matters is how many ounces, how much it costs per ounce. So now I have to remember gallons. Oh, yikes. All right. So 1 gallon I know is 4 quarts. And I know that 1 quart is equal to 2 pints. And 1 pint is equal to 2 cups. Okay. So 1 gallon is equal to, we could say 1 quart is 2 pints. So that's 8 pints. And remember, 1 pint is 2 cups. So 1 gallon equals 16 cups. And a cup is 8 ounces. Okay, so here I would do 16 times 8. And that'll tell me how many ounces we have. Okay, remember, 1 cup, I'll put that off to the side, is 8 ounces. So 16 cups in a gallon is 16 times 8. So let's see, 6 times 8 is 48, carry the 4. And then we get 128 ounces. So 1 gallon is 128 ounces. So if now we do a proportion here, if it's $1.79 for 5.5 ounces, this is going to be equal to X dollars for 128 ounces. Oh, yikes. Without a calculator? This is just like unnecessarily, torturous. But let's do it. All right. So 5.5x equals, and oh yeah, there's probably a ton of traps. Hopefully I didn't step in like 10 of them already. Whoops. All right, so we're multiplying 128 by 179. And then I'll just move the decimal over later. All right, so 72. Carry the 7. 56 plus 7 is 63. Yeah, let me just make sure. 72, carry the 7. 56 plus 7 is 63. Carry the 6. 14. Put a placeholder. 2 times 9 is 18. Carry the 1. 2 times 7 is 14 plus 1 is 15. Carry the 1. 1 times 1 plus 1 is 2. 2, 11, and then 10. Carry the 1. So 128 times 1.7. Wait a minute. Why does that seem off? Give me 1. Why does that seem so weird? Because it should be more than 128. But 128 times 2 would be like 256. I blundered somewhere. Let me do that again. Sorry about that. What got thrown out of whack? Let's see. 8 times 9 is 72. Carry the 7. 56. 56 plus 7 is 63. Oh, carry the 6. 8 times 1, so this is 14. I might have had that already. 2 times 9, so now I'll get rid of these. 2 times 9 is 18, carry the 1. 2 times 7 is 14, plus 1 is 15. 2 times 1 plus 1 is 3. Oh, 2 placeholders. Maybe I just didn't do that last, I don't know, whatever. 1 times 9 is 9, and then 7, and then, oh, I didn't do the last row, that's why. I don't know, I don't remember what I did, to be honest. 19, and then, I'm just warming up here. So I'm getting warmed up. All right, now I'm warmed up. So this would be, yeah, 229.12. Seems about right. Yeah, 128 times 1.79 would be 229.12. That's more reasonable. Okay, because it's not double. It's like a little less than double. That makes sense. So now 5.5x equals this times this is 229.12. So now divide. Yikes. Let's see. How much more would a gallon of orange juice cost than a gallon of milk? Unless it would be easier to multiply this. Let's just see. Oh, wait a minute. Ooh, there's a 6-pack. All right, so you know what I'm going to do? Like, if I had a question like this, I'll come back to this one. This one's just annoying. I kind of, so just reacting to this question here. It's a 6-pack. So that does come into play. Each bottle itself is 5.5 fluid ounces. Oh, I think that might make it nicer. Hang on a sec. 55 times 6. 30, carry the 3, and then 33. So that would be 33 ounces. For a, yeah, okay. So that changes the story here. 6-pack, each of 5.5 fluid ounce bottles. Yeah, the 6-pack of the bottles themselves, that makes more sense, or 5.5 fluid ounces. So all right, you know what? I just went on this like long expedition here, and I didn't need to. So let me just doctor this up a little bit. Okay. So what it's costing for the OJ is it's costing $1.79 is for 33 ounces. And we said a gallon is 128 ounces. So milk is 128 ounces for $3.99. Oh, okay. So then this, I think, yeah, this one here, we would just have to get this up to a gallon. 66 and 1. So let's just see. How much would this cost per gallon? Yeah, this one, all right. So I think this might make it a little bit nicer. So if it's $1.79 for 33 ounces, how many dollars is it for 128 ounces? Oh, wait, I just did all that work again. Yikes. Let's just see. Yeah, I'm going to come back to this one because this one is like just, it's pretty tedious. There's probably an easy way of doing it because here's the rule with math. If you're doing something and it's taking you a really long time, there's probably an easier way. So I'm going to like come back to 61. So 61, I'm coming back. All right. So, and just know if like, I don't know how much time you have to do a test like this, but I would take that into account and I would save something like this that's tedious for the end. So monthly high temperatures, the box plot shows the average monthly high temperatures in New York City for 12 months. What is the difference between the range? Okay, so the range is, oh wow, wait a minute. They're counting by fours, and this is not lined up with anything. So I'm gonna guess 38 is here. Is that 39? Yeah, so I'm already not liking this question either, but whatever. So let's see. This would be 545. What is the difference between the range and the interquartile range? So the interquartile range is the difference between Q3 and Q1. So this is Q1 over here, and this is Q3. So this one's a little bit more straightforward. So that'd be from 78 to 48. And that's 30. So now the difference between those two is 15. All right. I mean, that, yeah, like that one is pretty much more direct. Okay. So there we go. 15. But 61, I'm going to, I love 61. I like any question that's annoying. I do like this one here. So let me just get this out of the way. Yeah, and also like the one thing, like as I'm erasing this, I did an SAT practice yesterday, math practice, and I got to 800 when I did the practice, which was cool. And I did it within the time, but when I did it by myself, it's like I'm just not talking. I'm just like, all right, all in with the math. Like when you narrate as you're doing it, like you're definitely like not as effective. Like it's like it brings me down a notch. Like even though this is like a middle school test, like it's definitely a nice one. But 61, I'm gonna come back to and give it a second thought. So here we go, multiple choice. What is the prime factorization of 256? All right, so we have at least, well, it's divisible by 4. I know that because every answer choice has 2 squared. So I would divide this by 4, and we got 1, remainder 3, 8, remainder 3, and then 9. So this is 189 times 4, which is the same thing as 189 times 2 squared. And then 189 is divisible by 9. So I know it's going to have a 3 squared. Is it divisible by 3 to the third, though? But whatever, I'll just divide it by 9 first. So 9 goes into 18 twice, 9 goes into 9 once. So, okay, so it's 2 squared times 9 is 3 squared times 21. I could call 3 times 7. So then 3 to the second times 3 to the first is 3 to the third. So this, and 2 squared, 3 cubed, 7 is choice D. Okay? All right. Yeah, no, honestly, I would save my least favorite question for the end. Like that's, if I anticipate something's going to take me a long time, I don't use all my time. Like that's just not a good strategy. What is the value of this expression? All right, so x to the second, you're going to have to put in parentheses 2 to the 6th power over, we've got -2, and then 2 to the 2nd power. Now, the trick here is don't actually multiply this out. Just know that -2 squared is the same thing as 2 squared. So, like, these things here cancel. They're going to be equal. And then this, now we have just a negative left on bottom. So the answer is negative. So if I did guess, like, it's going to be E or F. And now here, I could rewrite this as, and I'll put the negative like actually after. So let me cross these off first. I know it's negative, but I'm gonna put the negative here on the outside, and I'll have 2 to the 6 over 2 to the 1st, which simplifies. We're gonna have negative and then 2 to the 5th power, and 2 to the 5th power is 32. So this is gonna give us a -32. Okay, so yeah, I'd have to see like pacing wise, because if you have to rush, that's going to definitely affect your accuracy. But at the same time, like if I have more time, I'm going to make sure to like really double check my answers if time permits. So 8 over m plus 4 equals 20. Subtract 4 on both sides first. So 8 over m equals 16. And m is a half. All right. I mean, some math you just do in your head, but if you have cross multiply, you got 16m equals 8, divide by 16. And then 8 over 16 reduces to a half. So choice B. What is the value of x here? All right, so this one, subtract x on both sides. And you'll get 5x equals -1680. Then you divide both sides by 5. You know your answer is negative, so it's G or H. And then x equals negative 16 over 5 is 3 with a remainder of 1. 5 goes into 18 3 times with a remainder of 3, and it goes into 36 times. So negative 336. All right, so here we go. We're flying a little bit. Oh, you got shrimp tempura. Very nice at RyanTube. I'm happy that you got your sushi. Thank you so much for letting me know. Congratulations on getting your 100 too. That, like, once again, the 100 on geometry, very impressive accomplishment for sure. So awesome stuff. All right. So coming back here, a person buys a used car with a down payment of $1,200 and makes monthly payments of $275 for 3 years. Okay, so a person buys a used car, they put $1,200 down, and they made monthly payments of $275. So monthly, you've got to do this times 36. Okay, so yeah, so 1 year is 12 months. 3 years, if you multiply by 3, is 36 months. So if they're doing monthly payments of $275 for 3 years, that's $275 times 36. What is the total amount they paid? We're going to have to add the $1,200 when we're done. So 30, carry the 3. 42 plus 3 is 45. We carry the 4. 12 plus 4 is 16. Placeholder, then 15. Carry the 1. 22. Carry the 2. And then 8. 0, 0. Carry the 1. 9. So that's 9,900, but LOL, don't choose this. B for bear trap. You got to add the 1,200. All right, don't be so proud of yourself that you remembered how to. Assuming though this, yeah, so 11,100 I'm going with. Yeah, oh yeah, RyanTube, Fortnite Sweat. You guys should totally talk, because I feel like at Fortnite, like, you could. I feel like you're right on that. You're on that level too. 100 on the Regents is definitely within reach for you. That it's August, school hasn't started yet, and you're doing like recreational math. Oh, let's see. What is the total amount the person pays for the car? Oh, because it's a down payment. So the down payment is just like kind of like the fixed. Like if you think like y equals mx plus b, like the 1,200 is the fixed amount. Yeah. So it's not like the monthly payments, like that's why for the monthly payment of $275, like that gets multiplied. So that's, yeah. But the down payment is, I put a link in the description. So at it's a special. Oh, what is the test? It's the specialized high school something. Fortnite. Yeah, you could brief. You could say more about what this test is. But it's a specialized high school exam. It's to get into the best schools in the high school. To get into the best high schools in New York, this is the test. So, just know, in a parallelogram, the consecutive angles add up to 180. Okay, so 3x plus 2x equals 180. So this is just some textbook geometry here. All right, and it's a standardized test, and it's time, so I'm moving quickly. 5 goes into 18 3 times with the remainder of 3, and then 36. The value of x is 36. All right. It is a difficult. I like this test. I like the challenge. And I got to do like a million of these questions too. It's even more heroic. Oh, I still have some coffee. Let me finish that. All right. That's my unfair advantage. Question 69. A bus begins its trip with R occupants, including the driver. Okay, so the bus, there's R people. At each of the 20 stops, 3 people get on and no one leaves. Okay, so that's 60 more people. All right, at each stop, 3 people get on, no one leaves. If there are 3 times as many bus occupants at the end of the 20th stop as there are at the end of the 4th stop. Ooh. Oh, wow, I like that. Okay. So let's just see here. Let's make a table here. So at 1, 2, 3, 4. So at the first stop, a bus begins its trip with R occupants. At each of the 20 stops, 3 people get on. So at the first stop, that's going to be R plus 3. And then 3 more people get on. That's r plus 6. And this is r plus 9. And this is r plus 12. Okay, so this is a significant value here. So what they're telling us at each of the three people get on, no one leaves. So this is kind of like an arithmetic sequence, like it's behaving like. But now I'm like ... At the end, at the 20th stop, we care about. So let's look for a pattern here. Like 1 brings us to 3, 2 brings us to 6, 3 brings us to 9. Times 3 is the pattern. So if I want to say what's like r plus, it's going to be r plus 60. Okay, so 60 more people get on, which makes sense. Three people get on at each stop. No one leaves. So these are the values we have to compare. However, the comparison that they're making here is, let's see, if there are 3 times as many bus occupants at the end of the 20th stop, what they're saying is that r plus 60 is 3 times as much as r plus 12. Okay, so think about that one more time. If there are 3 times as many bus occupants at the end of the 20th stop as there are at the end of the 4th stop, how many occupants did the bus have immediately after the 10th stop? Okay, so then we have to solve for what's going on at the 10th. So at the 10th stop, it's r plus, remember, 4 times 3 was 12, 3 times 3 is 9, so 10 times 3 is 30. So we have to solve for what is r plus 30. Okay, so here, just algebra. So let me zoom out a bit. Do I have space anywhere else? Yeah, it's like space is a little bit of an issue here, but whatever. So r plus 60 equals distribute 3r plus 36. So that's going to give us 2r when we subtract r, and then subtract 36, and that gives you 24. So r is equal to 12. So if we want to know what is r plus 30, the 10th stop, r plus 30, 12 plus 30 is 42. Okay? And if you even wanted to like check for this, remember the first stop, so 12, so that's 15, then 3 more, 18, 3 more is 21, and then 24, 42. If we plugged in 12 here, that's going to give us 72. And if we did 24 times 3, that does give us 72. So these numbers are looking good. I'm happy with that answer. Yeah, it's a hard question. This is mean. All right, let's see. Jay sold N tickets. It's like a very bear trappy question. Jay sold N tickets. So Jay, you're N. Pilar sold 3 times as many tickets as Jay. So Pilar, you are 3N. Together, Jay and Pilar sold 10. Ooh, all right, let's see. So together, that's N plus 3N is 4N. Sold. All right, let's see. So I'm just going to write it out in stages. Together, they sold N plus 3N. They sold 4N. But now here it is. Together, Jay and Pilar sold 10 more tickets than Amy. So we have to be careful here. It's very tempting to say G, but I feel like G's not it. Yeah. You're like, oh, 10 more than together. Like that's, they want you to move quickly and mess up. So think about this carefully. Like Amy, I'm going to call A. So there's Amy, and I'll use lowercase a. So Amy and then together is 4N. But they're saying that, think about it carefully. Together, Jay and Pilar sold 10 more tickets than Amy sold. So that means like they would be equal if we gave Amy 10 more tickets. All right, read that a few times carefully. Together, Jay and Pilar sold 10 more tickets than Amy sold. So we could set their together amount 4N equal to A, but we have to give Amy 10 more tickets for it to be balanced. But they want us to know which expression shows how many tickets Amy sold. So we have to do minus 10 here to solve for Amy. So Amy would be 4N minus 10. Would be choice H. Yikes. That is really tough. This question is, yeah, this test is like pure evil. I'm glad you found it. This is I feel like I would have never thought to do SHSAT. I like these questions though. These are really challenging. I can see why you need to, like, this is a specialized high school test. Yeah, definitely like hard stuff. I hope I get into one of the good schools. I just fail this and I don't go anywhere. Yeah. No, I think I wouldn't fail it. This is practice though. Remember, this is just a practice run. All right, so negative 12. For what values of x is the above inequality true? So divide both sides by 6, and you got negative 2 is greater than x. And like, oh no, it says it this way. But just know, if negative 2 is greater than x, that has the same meaning as x is less than negative 2. Okay, negative 2 is greater than x means x is less than negative 2. If that didn't help, you could always do, something like this. Like you could go minus x on both sides. And that'll give you minus x minus 2 is greater than 0, and then do plus 2. And that'll give you negative x is greater than 2, and then you divide both sides by negative 1, but when you divide an inequality by a negative, the sign flips. So either way, x is less than negative 2. Choice C. All right. So moving on. If 5x minus 6y is 50y, what is the value of x in terms of y? All right, so this one, I'm going to write it over here. I just did a video recently on 100 linear equations, and we could distribute, or we could go like this. Divide both sides by 5, you get x minus 6y equals 10y. And then just add 6y. And you're golden. X equals 16y. So what is the value of x in terms of y? 16y. You think I could get in? Thank you. I appreciate the vote. But I want, like, the theme of this channel. I don't claim, like, it's tough. Like, when you get to the teacher spot, you don't want to, like, claim to, like, oh, I'm the best mathematician in the world right now is probably Terence Tao. Let me look him up real quick. So brief little tangent. Terence Tao. Make sure I'm spelling his name right. Yeah. You want to Google, like, the real GOAT of math. One of the GOATs. There's a few GOATs, I guess, but he's, like, definitely one of the best right now. And I feel like schools, like, they don't get enough of a shout out, the top mathematicians in the world. Yeah, like, I look at someone like him as like, oh wow, he's the best. But I see my job as a teacher is I just have to stay, like, really interested in math. I have to keep staying sharp. I have to keep staying sharp. And I have to try to inspire other people to, get into the math and try their best. That's how I see my job these days. Like, I always want to, like, put myself in spots like this so I can remember what it's like to be the student. Like, taking myself out of my comfort zone. But yeah, this guy's, like, the GOAT for sure of, like, knowing math. There's a lot of really, like, amazing mathematicians out there. So let's see. Scale, a half inch is 25 feet. A scale drawing of a new pool is shown. All the corners are right angles. What is the perimeter of the actual pool? Okay, so let's see. So this is one of those things. If this is 6 and this is 3, this is also 3. See, because, like, this entire thing is 6, so 3 plus 3. This would have to be 3, right? And it's because those are all right angles. And then same idea. Like, if this is 2, then this is 2, so then this would have to be 3. Because you see here, like, 3 plus 2 would give you the whole thing 5. All right, and did I even need to find? I didn't need to find that. Why did I find that? Oh, you know why I found that? Because if this is 3 inches, then this piece here is 3 inches. Because these are all right angles. Okay, so that just helps us find the stuff that we need. So the perimeter in inches first. We're doing 3 plus 3. Plus 5, plus 6. Oh, wait, I lost track. Let's try that again. So 3, let me see, 3 plus 3. So how about I label it? I'm starting here. So 3, I would probably trace it as I go. 3, 3, 5, 6, 2. So I got an extra 3 I got to add. Yeah, so I try to trace it as I go so I don't lose track. Especially as you get older, you start forgetting things. 6 plus 5 is 11. Plus 6 is 17. Plus 3 is 20. So 22. 22 inches. Okay, but what they're telling us here, we know every half inch is 25 feet. So really what we need to do is, I mean, I could just multiply this by 44. That works. Or I'll just do a proportion. Yeah, we'll just do that. So the scale, 25 feet, corresponds to a half inch in the diagram. So we've got 22 inches corresponds to x feet. So I would have a half times x equals 25 times 22. So now we got to multiply. Or you could say 500 plus 50 is 550. That works. If you want to do a little mental math. So mental math trick. What I'm doing in my head, I'm doing 25 times 20 plus 2. Make that pop. And then that's 500 plus 50. So mental math trick. So 550 would be this. And then double it to get rid of x. I'm sorry, double it to get x by itself. 2 times a half cancels. X equals 1100. So 1100 feet I'm going with. So nice question. Oh yeah, Nikola Tesla is very, very, very much underrated. Well, I mean, Elon Musk named Tesla after Nikola Tesla, so I think he gave him like such a proper shout out. But yeah, not enough. There needs to be more about the history of the really smart people in the world. So Maria rides her bike to school at a constant speed of 15 miles per hour. All right, so there's Maria going 15 miles per hour. If the distance to school is 6 miles, how many minutes will it take Maria to get to school? All right, so Maria goes 15 miles per hour, or I'll say she goes 15 miles per hour, which is 60 minutes. So if the distance to school is 6 miles, then how many minutes? All right, so you could always express miles per hour as miles per 60 minutes. Okay, so just that's a nice little trick to know. So this, I guess we could just do the algebra. 15x equals, do 6 times 6 is 36, and then just put a 0 at the end. And then divide by 15. So x equals 15 goes into 30 twice with the remainder of 6, and it goes into 64 times. So 24 minutes. All right, cool. 74. All right, in the figure above, so geometry time, we have n is parallel to p. These lines are parallel, so I'll put the symbol here for parallel. Straight line M intersects both of those lines. What is the value of r? All right. So this is 90, this is 73. Oh, so this is just going to become this game. All right, so let's see. How about if I go, no, that doesn't help. This helps though. In a triangle, there's 180. So far we have 90 plus 73. Oh, I just wanted to see this live, but I do not need an SHSAT, but you know it's best to see each of every math. Yeah, no, for sure. Jonathan, thanks for joining. It's definitely a good idea to practice math. Like, even though I'm not teaching this kind of, I'm teaching geometry and AP Calculus BC next year. So, I guess I don't truly need to know SHSAT math, but I just think it makes me better for teaching math because I'm just more comfortable explaining like just wide varieties of questions. So this is good practice for all of us. I'm glad you joined. So thanks for coming on board here. So I'm going to do 90 plus 73 is 163, and then I subtract that from 180, and that'll tell me what that small angle is over here. So now we borrow, and 17 degrees. Okay, so this one is 17, and now here becomes the game. Like if this is 17, just know when you have parallel lines cut by a transversal, the corresponding angles are congruent. So if this angle is 17 over here, that means this angle over here is 17. And now we just do 180 minus 17, which is going to be 163 because we just kind of did that before. But, you know, whatever. I'll just do it again. So 163 is the value of r. Okay, so parallel lines cut by transversals, you have corresponding angles formed are congruent. All right. And that you had a combo with the 180 concept. Once we know a triangle, the sum of the interior angles is 180. We know this is 17, that has to be 17. And on a straight line, you have 180, so that also works. Cool. 76. Parallelogram PQRS. Above, the length of QT is 18 centimeters. All right, the length of, I just said that. What is the area of the parallelogram? The area of a parallelogram is just base times height. So the base is 34, the height is 18. If you know the formula, I guess it's not too bad. You don't have to get too crazy here. Someone might fall in the time trap of like doing Pythagorean theorem or something to solve, but just know the area of a parallelogram is base times height. So the base here is 34, and the height, you see that 90-degree, straight line distance to the other parallel side is 18. So just do 34 times 18. So this one, it's like LOL. This is extra. Distraction, okay? So the traps in this test are very, powerful. Be careful. So 32, carry the 3, and then 8 times 3 is 24, plus 3 is 27. Placeholder, and then we have 1 times 4 is 4, 1 times 3 is 3. So this works out to 612 square centimeters. I'm going with this. All right. So let's see here. Allison has 5 stamp albums with 576 stamps in each album. Okay, so 5 of them. I don't know why I'm doing this. It just feels like I want to get this out there. 576, 576. Okay, I just want to put that there. If she transfers her stamp collection into 6 albums, each holding 378 stamps, how many stamps will be left over? All right, that's a good question. So first do 576 times 5. So 30, carry the 3. 35 plus 3 is 38, carry the 3. 25 plus 3 is 28. So that's 2,880 stamps in total. But she's transferring them to 6 albums. Each hold 378. So if you have 6 albums and they hold this many stamps each, do 378 times 6. So this is 48. We carry the 4. 42 plus 4 is 46. Carry the 4. And then we've got 18 plus 4 is 22. And now subtract. So how many left over? We have 28. Let me change colors here. 2880 minus 2268. So borrow. 10 minus 8 is 2. 1, 6. 612. Maybe I should write down my spatial thing. Yeah, so one comment I can make about just standardized tests in general, I do try to draw things out because it frees up space in your head. That's how I look at my paper. Like the more I put on the paper, and of course there's like a fine line, there's a balance, but the more I put on paper, the more like it frees up my brain to like really think. So yeah, that's definitely something I like to do. But like in this case, I didn't need to, but I just like to just in case sometimes. Depends on like my mood. That's why I always really like geometry, because geometry is like very visual. So I like that you could think creatively and have a chance to solve. All right, so here we go. 4 steps. Start with this number and perform the following steps in order. Multiply by 10. Okay, so after step 1, if I do 135.28 times 10, just know that moves the decimal 1 place over. So that's 1352.8. Add 0.5 to the result of step 1. So now the step 2, I'm doing plus 0.5. And that's going to give me 13. I carry the 1. That's going to give me 3. And then 531. Drop the digits after the decimal point. Okay, so that means we don't have a 3 anymore at the end. So we'll get rid of that 3. So 1353. And then divide by 10. So we divide this by 10. And we're going to get 135.3. Yeah, so choice H. That's it. Cool. All right. I hope that one's I hope I didn't step in like 10 bear traps, but whatever. Ooh, I like this one. If x is -2, what is the value of this? That's messy. All right, so here we go, just piece by piece. So I'm going to and I'll color code this. So parentheses. So you got -2 plus negative 2 squared plus negative 2 to the third minus, we've got negative 2 here plus 2 times negative 2 plus, let me move that over, plus 3 times negative 2. I mean, I could have just called this 6x. That might have been easier, but whatever. I'm already committed now. Okay, so this is negative 2 plus 4. And then negative 2 times negative 2 is 4, but times another negative 2 is minus 8. So simplify as carefully as possible. And now this one, we have negative 2 minus 4 minus 6. Probably should have gave more. All right, so I'll write it over here. Sorry that I'm zigzagging. So this is absolute value of, so going from left to right, negative 2 plus 4 is 2, and then 2 minus 8 is negative 6. So I have absolute value of negative 6 minus, not plus, minus the absolute value of, and negative 2 minus 4 is negative 6, and minus 6 is negative 12. So this is going to give you absolute value of negative 6 is 6, minus absolute value of negative 12 is 12. So this works out to negative 6. Choice B. All right. 0. 3 plus negative 3 equals 0 over 3 minus negative 3 is 6, and 0 divided by 6 is 0. I hope it's that easy. Yeah. Cool. 82. What is the distance between the midpoints? All right, here we go. We got to think. What is the distance between the midpoints of MN? So MN is here and here. And the midpoint you could find by eyeballing it or finding the average. So if I did 1 plus 7 over 2, that's the midpoint of MN. So minus, so we have this, minus, so what is the distance between the midpoints of MN and RS? So RS, we would do 3 plus 6 over 2. And I'm going to put this in absolute value. Let me see, 4 minus 4.5. Yeah, so let me do this. Because with this one, like, distance is always positive. So, yeah. So this is going to give you absolute value of, we're going to have 8 divided by 2 is 4. And then minus, let's go change colors here. So minus, and this one, if you had 9 divided by 2, that's 4.5. So then, yeah, this becomes negative 0.5, which is 0.5, which is 1/2. So choice E. Yeah. Cool. If S is a positive integer and T is a negative integer, which of the following expressions must be a positive number? Okay, so S is a positive integer, so I don't know, just make it like S equals 3 and T equals negative 2. So you see, like, this would be 3 minus negative 2, which is 5. So 1 would always be positive. So must be. Must means there's no other possibility. All right. So 2 tells us S times T squared. That would give us 3 times, we would have a negative integer, but squared. So yes, this would give us 12. Like, this would have to be positive also. And now let's think about this. Which of the following must be a positive number? Now, notice they didn't mention integer. Okay, so for this one, like 1 has to be included here. So now it's between B and D. Like, is 3 in the mix? So which of the following must be a positive number? They didn't say positive integer. So that is like sneaky wording to be on the lookout for. So S to the T power. So S is 3. Now to the negative second. That's the same thing as 1 over 3 squared, which is 1 over 9. So just know, if you have an exponential function like this, like y equals, yeah, like something, actually, I don't know if you use that notation. But if you have a positive base, I'll just say it like that. How about this? Yeah, like if your base is positive, a positive number to any power is greater than 0. Okay, so that means, like, yeah, this one will always be positive also. People see, like, ooh, negative exponent means it's negative. No, that's 1 over 3 squared, which is 1 over 9. And 1 over 9 is positive. It gets really small. You know, like, let's say I had 3 to, like, the negative 100. This is 1 over 3 to the 100, which is a tiny number. That's like 3 times itself 100 times. And you do 1 divided by that. That's a small number, but it's still greater than 0. Okay, so 1, 2, and 3 is our answer. All right, what is the value of this? So negative times negative is positive. So these aren't it. And this you could reduce ahead of time or do it later. So 3 times 2 is 6. 4 times 5 is 20. And then just reduce. And it's 3/10. So choice G. All right. Uh-oh. You got to think. Yeah, these questions are like really painful. All right. Yeah, anytime I see a question like this, there's like a million things. I'm like, all right, here we go. Just get ready to think. These are like my favorite. They're easy. It's just like, yay, I move. And these, I'm like, all right, think. So the table shows the income and expenses in a bicycle shop on one day. So income, that's money coming in, and that's like money you have to spend. The sum of all transactions was $70. What is the value of P? Okay. So just know expenses are like negative. Okay, so think of these as negative. Because you're, in a sense, like you're a profit. This is like kind of like economics territory. Is like revenue minus cost. Okay, which is kind of like income is the same thing as revenue, and expense is your cost. So we have to just treat the expense column as negative. All right, so what they're telling us here, they sold 2 bicycles. So for $400, like I'm just thinking here, like, all right, that's $800. They sold clothing for $95. And they sold bike parts for P dollars. So P I'm just going to write like at the end. Like, so P plus the sum of these, it's going to be 598. Okay, let me just write that a little neater. So 895. So that's their total income was P plus 895. Now the expenses, they had to pay employees $120, 4 of them. That's $480. Okay, so that's 480. So I'll just write that here. 480 plus 500 is 980. So basically, like we have P plus 895, but minus 980. The sum of all the transactions was $70. So here I would just do 980 minus 895 on the side, but make it negative because 895 minus a bigger number is going to be negative. So here, make that a 7. 10 minus 5 is 5. Borrow 17 minus 9 is 8. So 85. So it's going to be P minus 85 equals 70. And then just add 85. All right. That was an annoying question. 155. That's my final answer. Okay. So Dakota has 4 yardsticks and 2 12-inch rulers. If she lays all 4 of the yardsticks in both rulers end to end, what is the maximum number of feet she could measure accurately at once? Is this just asking for the total? All right, well, I'm just going to start working this out. So 4 yardsticks. So that's 3 feet. 3. Make that a little more uniform. So 4 yardsticks and 2 12-inch rulers. So make this, so that's 1 foot. Okay, because remember, a 12-inch rule, 12 inches is 1 foot. So if she lays all 4 of the yardsticks and both rulers end to end, what is the maximum number of feet she can measure accurately at once? Is it just as simple as adding these all up and converting units? So that's 3 times 4 is, that's 12 feet plus 2 feet. Is it really just 14 feet? All right. That'd be it. Okay, in a fruit basket, the ratio of apples to oranges is the same as the ratio of cherries to walnuts. All right, so apples to oranges is equal to the ratio of cherries to walnuts. I don't know why I want to set that up. All right, here we go. If there are 6 oranges, so now this helps. 6 oranges, so 6 goes by oranges. 16 cherries. 48 walnuts. How many apples are there? All right, so this you could multiply, but I think an easier way is to reduce. So I would say x over 6. This one I'll divide top and bottom by 16. And now it reduces to 1/3. Okay? This you could even just say times 2 times 2. So like x is 2. That works. Or you could just do 3x equals 6. But either way, x equals 2. So 2 apples. What conversions do I need to know for like state tests? I mean, I would say, yeah, like feet, inches, yards, feet. I don't think they would ask you to know kilograms to pounds, even though like a kilogram is 2.2 pounds. I know that because I taught physics for 2 years. But yeah, like seconds, minutes, hours. It's going to be like all like, you know, US measurements. I don't think they're going to go like too heavy on the metric system. Although we should take on the metric system. But yeah, stuff like that, I would know. So this one, all right, you set up the ratio, but then they scramble everything. So that's what makes this question annoying. Hopefully I didn't miss any details. All right, in a showing of an artist's work, the ratio of the number of paintings, drawings, and... Oh, so continued ratios. Here we go. 3 to 5 to 4. So paintings... I'd have to look that up, though. So paintings, hopefully they don't have the same... Oh, yeah, of course they do. So paintings, drawings, and photographs. If the number of drawings shown was 45... So I'm just lining it up. You see how drawing is 45? I'm lining that up here. What is the total number of photographs and paintings? Oh, what is the total number of photographs and paintings? Okay. So look for the scale here. 5 times, I call that like the K value because it has like that similarity concept or dilation kind of idea. If I do 5 times 9, I get 45. If I do 4 times 9, so times 9, so we're going to multiply by 9, we're going to get 36. And if we do this times 9, we get 27. Okay, because 5 times 9 is 45. So they want us to solve for, see how 36 shows up? Like they got us. What is the total number of photographs and paintings? So we got to add those two. So 13, carry the 1, 63. All right, cool. There's the 9th grade section. I'll do that on a different date for sure. Is it on the same document? I just picked something at random. I didn't realize there was a 9th grade SHSAT. I always thought that like specialized high schools, like you take it in 8th grade to get into high school. But that's cool to know. But yeah, down the line, I'll do a 9th grade one. Why not? All right. So for each 3/8 foot of curtain, wait. Oh, okay, I get it. All right. So for each 3/8 foot of curtain width, 5/6 yards of fabric is needed to make ruffles. All right. So that is kind of silly. So 3/8 foot, 5/6 yard. So this is like width and ruffle. I don't know why I just want to set up a ratio. How many yards of fabric are needed to... So how many yards of fabric are needed per foot of curtain width? Okay, so how many yards of fabric are needed per 1 foot? So now I want 1 foot of curtain width. How many yards? So this one, there's a nice little trick for this. Like, how do you get from 3/8 to 1? You could just multiply by 8/3. Just know, yeah, like 3/8 times 8/3. Anytime you multiply a fraction by its reciprocal, as long as there's no 0 involved, it equals 1. So I just multiply the top and bottom by 8/3. And yeah, that'll get us the answer fast. All right, otherwise I put an x and I just cross multiply. So either one works. I like this way more though. So then I'll just do that on the side here. So we have 5 over 6 times 8 over 3. And that's going to give us 40 over 18. And then this we could reduce by 2, dividing by 2. And that's 20 over 9. Okay, so 20 over 9 yards. Choice C. Oh, so there is a 9th grade. All right. I'm probably not going to do that today because if I got to get to question 114, that's going to take a while. And like, I have like, yeah, other stuff I have to do later in the day. Like sadly, I can't be streaming for more than like 3 hours really. So I'll on a different date for sure. I'm going to be doing an SAT live stream this Friday because the SAT is on Saturday. So I seem to be just getting pulled in the direction of being like the practice test guy, which is fine. You know, if that's like what people want to see, then that's what I'll keep doing. So yeah. All right. And to the people who joined, yeah, thank you for supporting the live stream, and the people watching, thank you for, you know, watching after the fact what we're doing. It's very short though for 9th grade. Oh, that's good to 17 questions. Yeah. I'm also like probably going to feel like your brain has like limited battery power. Like I think one test will be for sure though. I'll throw that in though, like for fun, like, you know, at some point. So which straight line is the graph? Whoa. All right. Wait, is this, what are they even asking? All right. Which straight line is the graph of a proportional relationship? MS, VP, VQ, or TR? Oh, well, it has to go through the origin. Because when I hear directly proportional, I think like y equals kx. And any line like y equals kx, like will go through the origin. So I'm leaning towards this. But like 90 is the question I would circle just to be sure. Yeah, just to be certain. Yeah, you know why? Let's see here. Because if I take this point here, let's say the point 0.08, and I compare it to 8 over 0. You know, I can't say like, all right, 8 over 0 equals like 0 over 8. Like that doesn't work. Okay, like if I do like the y over the x equals the y over the x, like no, doesn't work. But this one, aside from 0, 0, like if I take 4 and 1, like, so this is the 0.41 and this is the 0.82. Like for this one, I could say that, you know, 1 over 4 equals 2 over 8. Like that works for TR. So that's why it's this one. You know, even if this line is like just kind of missing that point. Okay, even if you did this point here, like 1, 7, and then you compare it to like, you know, 4, 4. See how even that, like, you're like, all right, 7 over 1 equals 4 over 4. Like, nope. No, it does not. So TR is the one. Because it's y, it's in the form y equals kx. The line has to go through the origin. All right, 91. So ice costs. Let me just, I guess, zoom out a smidge. Some friends are buying bags of ice for a picnic. The graph shows the cost of the ice in dollars in relation to the weight in pounds. Which statement about a point on the graph is true? So 23. That's on the graph. 1, 0.15. All right, so all of these points are actually on the graph. So now we have to make sure we understand what this means. It means that 3 pounds of ice costs $20. No. You see how like 20 is the weight. So let me actually write this in. Like 23, like this is the weight. And this is the cost. So just read the graph carefully. The 3 pounds, no, so this is out. Means 1 bag of ice, no, 1 pound. So you see how it's the weight of ice in pounds. So 1 pound would be better. So 10, 1.5. So this means 10 pounds of ice cost $1.50. Yes, this one is sounding the best, but let's see why. Wait, 0 means that 0 pounds of ice will be needed if 0 people go to the picnic. They're not talking about people, and yeah, so this one's just like kind of strange. I mean, that's like kind of, but it's about which statement about a point on the graph is true. 0 pounds of ice costs $0. Not how much ice will be needed if 0 people go. So C is our best answer. All right. Oof. A lot of graph information entered. All right, good to know. What does it need to be proportional? Does it mean like it's not a fraction? Well, it just means that all the points on the line are proportional. So if I go back to 90 for a minute. So like no matter which point you pick on this line, 1/4, so the y has to be proportional to the x. Y equals kx. They have to be directly proportional. So that's what we mean by that. So the y and x are going up at a, like, you know, if I look here, if I made a table, it's like, all right, 0, 0, but like 4, 1, 8, 2, you can see here like 12, 3 would be the next significant point. But no matter what, like 3/12 equals 2/8 equals 1/4. Like the x's and y's maintain that same proportion. Okay, and if I had to actually solve here, I could say like y equals 1/4 x. So that's the proportion here. All right, or you could even say like 4 times the y is equal to the x. So that proportion is held. All right. So let's see here. So a clerk enters information on a computer. Time, keystrokes. The graph shows the relationship between the time in hours and the number of keystrokes the clerk makes. What is the meaning of the point 1.5, 10,500? Okay, so remember, this is the time in hours, and this is keystrokes. So this is like the same question as before, sort of. That's what I'm getting out of this. A clerk makes 10,500 keystrokes in each hour of entering. No. The clerk makes 10,500 keystrokes in 1.5 hours. So this one looks good. The clerk makes 15,750 keystrokes in each hour. No, they don't. In each 1.5. No, that also is no good. Too much. Yeah, so this one, they make 10,500 keystrokes. So, because remember, the y-axis is keystrokes, and the x-axis is hours. So they make 10,500 keystrokes in each 1.5 hour of entering information. That is the rate. Okay, it is directly proportional. See how it's a straight line? So that's why it's a proportional relationship. All right. Oh, back to numbers. Here we go. Yeah, I kind of like when you get like a little break from these like very wordy questions. So when the 3-digit whole number 270 blank is divided by 3 or 4, the remainder is 0. What is the missing digit? Okay, so this number has to be divisible by 3 and 4. Well, 0 doesn't. I mean, I guess you could just go trial and error, like 270, 272, 273, 276. So I could eliminate 273 right away because it's not even, and 4 will not divide into this because it's not even. All right, you could even do the long division if you want, but remember, for a number to be divisible by 4, like the last 2 digits. So I'm like, oh, 73 divided by 4. Like, nope. 70 divided by 4. No, that's not divisible by 4. Remember, you could always divide a number by 2 twice. Like if I did 70/2, that's 35. But then if I try to do 35/2, like not divisible by 2 evenly. So like this one's out. 70, these two are divisible by 4. 72 divided by 4 is what, 18? And this one would divided by 4 would be 19. So then I have to check to see if these are divisible by 3. And the way to check if something's divisible by 3 is doing the sum of the digits. So 2 plus 7 plus 2 is 11. That is not divisible by 3. But this one, 2 plus 7 plus 6, is 15, and 15 is divisible by 3. So 276 would be the number, so it would have to end here in 6. So divisibility stuff. If you wanted to verify, though, like you could actually do like 276 divided by 3 is 92, and 276 divided by 4, make that neater, and I'll write it lower. 4 goes into 27. Why am I blank? 6 times. And then you get 24, remainder 3. So yeah, 69 times 4 is 276. So choice D. Okay, so question 94. Food consumption of the average American per year. Fruits and veggies. Wow, 38%? That doesn't seem right. I feel like Americans don't eat 38% of their diet as fruits and veggies. That just seems wrong. All right. Based on the circle graph, how many pounds of milk and eggs does the average American consume each year? Total consumption, 1,840 pounds per person. So we have to find the sum and subtract from 100 because it's 100% in total. So far we have 38%. Then we have 10 for cereals, 10 for meats and fish, 8 for sugar, 4 for oils and fat, or fat and oil. All right, 8 plus 8 is 16, plus 4 is 20. We carry the 2. And then 70 so far. So that's 30% that's missing. So x equals 30. All right, so just be mindful of that. So based on the circle graph, how many pounds of milk and eggs? So we just have to take now 30% of 1840 because the total consumption is 1,840 pounds. So 1840, we're doing 30% of that. But just know when I do like times 30%, that's the same thing as doing 1840 times 30 over 100. Okay, and 30 over 100 is the same thing as 3/10, which is 0.3. But I just want to see something. If we do... Oh, you know what I could do? Times 3 over 10. Watch this. And when I divide by 10 here, the trailing 0 crosses out. So I just have to do 184 times 3. Yeah, that's the easiest way. Take 3/10, and then you just have to do times 3. So that's 12. Carry the 1. 24 plus 1 is 25. Carry the 2. And then 3 times 1 is 3 plus 2 is 552. So we consume 552 pounds of milk and eggs. Why does that sound gross? I guess if I had to do it all today, that would be horrible. Cool. How many more? I guess we're making progress here. All right. Out of 2,000 high school seniors, 191 were enrolled in the Honor Society. What percentage of the entire group of 2,000 seniors were in the honor? So this one I think we could just approximate. So you see how these answers are far away from each other? So here I would say like 191 is like roughly 200. So almost 200 seniors out of 2,000. Cross off the trailing zeros. So that's roughly 2 out of 20, which is 1 out of 10. No, that is 2 out of 20, which is 1 out of 10. So 191 out of 2,000 is roughly 1/10. And 1/10 is the same thing as 10 out of 100, which is which is equal to 10%. Okay, so 191 out of 2,000 is almost 10%. And this is definitely close. Like the other ones are like kind of nowhere near 10%. So choice C. Don't actually, like I would approximate that one. I wouldn't sit there and do the long division. If there was an answer like 9.57%, like then I'm like, oh, all right, I got to do the division myself. But because this one, like everything's so far away, just do that. So tricks, some tricks for the SHSAT. Common sense will save the day sometimes. So 96. Number of visitors to the Brookside. I almost said Bronx Zoo. I don't know. The Bronx Zoo is like really nice. So number of visitors to the Brookside Zoo. So, all right. The table above shows the number of people who visited the zoo in one day. The largest of the 4 groups made up what percent? So the largest, all right, is 360. But now we got to find the totals. So 360 plus 340, 0, 0, 1. So 700 kids went. And then if I add up the adults, It's 500 adults. So 360 out of, in total, so the total here is 1200. All right, you can even add up this column too, like 0, 7, 5, and this is 0, 3, carry the 1. 570 plus 630 is also 1200, but it's this. And now cross off the 0. 36 out of 120. Does that divide nicely? I would just keep maybe reducing this. Divide by 4. So after you cancel, divide by 4. So you get 9 over 30. Divide by 3. Oh, here we go. Now we're on to something. And we get 3/10. And that's 30%. Okay? Because that's the same thing as 30 over 100. So, yeah. 30%. I'm going with that answer choice. I'm going a little bit quick, somewhat quickly here. So, yeah, that could be changing things. All right. Moving on now. Question 97. A bag contains 40 tiles that are either red, green, or blue. Okay, let me just write that out. Red. Let me write it in black because I feel like if I write red and green, it kind of ruins my head. All right, red, green, blue. Right, and there's 40 total. A tile is selected at random, the color is recorded, and the tile is put back in the bag. This process is carried out 120 times, and 18 of those times a red tile is selected. Based on the information, what is the most likely number of red tiles in the bag? Okay, so if the process was carried out 120 times, and 18 of those times, so that's 18 out of the 120 was red. This is like 1/6-ish. So I would do this times 40. Okay, so this is like the, kind of like the probability is like the number of times out of the number total. Okay, so how many times did it happen out of the total amount of times we did this? And then we just multiply that by 40. So 40 over 120 reduces to 1/3. Okay, so just do, like you're essentially doing, divide the top and bottom by 40. And then 18 over 3 is 6. So 6. Okay, so that works. Don't turn this into a decimal or simplify this. Like, just know you could cross cancel here. All right, you could, once again, you're doing like 18 times 40 over, technically, this is 120 times 1. But 120 times 1, like I could rewrite 120 as 40 times 3. And I could write the times 1, but I don't need to. But 40 over 40 cancels. That's why, once again, this is 6. So choice A, I'm going with. Making sure they said, all right, red. Yeah. Okay, so red, red, red. Yeah, I'm just making sure there's no traps. So last year's total attendance, children, adults, seniors, total. If 100 individuals will attend the museum next week, what is the best estimate, based on last year's attendance, of the number of children who will be in that group? Okay. So there are 1,750 children out of 5,000. And 100 people are attending. So let's see. I guess we could just do, 1,750 out of 5,000 times how many 100 individuals will attend next week. So like the percent here is 1,750 out of 5,000. Like, yes, technically times 100, but like, let me just rephrase how I'm saying this. So it's, so the theme here, I'm just thinking out loud, is part over whole. So I take this decimal here and I multiply it by 100, and that'll give us, what we need. Oh, so we got a comment here. So do you think 2 months of tutoring before the test is enough to get into Lehman, even if I study by myself? So, Legend, YT Albert, thanks for the question. My best response here is, let me just think. It depends on how much you're starting with, all right? Because every student is different. I would say if you're doing practice tests and you're doing like exceptionally well, then you're most likely good. I would say like relax a little bit and try not to burn yourself out too much. I was on SAT Reddit the other day, and like there was a guy who posted that was getting like straight, like, 1,500 and up. And they're like, hey, everybody, do you think I'm going to get a 1,500 on the actual test? And like the best comment was someone who also did well was like, yo, like you did a lot of practice. Like just if you're already like doing amazing, like you're good. So I would go by how you're doing like on your practice test. Like if you're doing amazing on your practice test, then like it's probably like good reason. Like you put your time in, you practice, and like just enjoy the fact that you are now next level. Because I think back, I'm not gonna name names. I've had so many students in my time, but there's like one in particular I'm thinking of. And if you're watching the replay, you know I'm talking about you, but in a good way. This student was always doubting himself, like, oh no, like I don't have confidence. I don't think I'm ready. You know, and they took the AP test and they got a 5. Like AP Calculus BC, they got a 5. And I was like, yeah, like I don't want to tell you I thought you would get a 5, but like they had gotten 90s and up on their math regents too. Like they were just, you know, great student all around. But like I was like, I have nothing left to teach you except like build some confidence. I'm like, you should eventually someday you're gonna have to be like somewhat proud of what you accomplished. Like don't be too proud. Like too much pride is every superhero's downfall. But if you put in the appropriate amount of time and you're doing well on practice tests and you're doing well on in-class exams, like chances are like you will do well. But look, if you don't get into your dream school, there's a lot of life lesson to learn from that as well. Sadly, like one of the skills you have to learn in life is how to deal with rejection and like not always getting what you want. Like it's like, it's a letdown, but like hopefully that just motivates you to like stay the course and stay active. But I would say, yeah, like 2 months of tutoring, like you putting in 2 months is like solid work. It's going to up your chances by a lot than somebody just showing up and taking the test cold. So 2 months of tutoring is pretty solid. But I know there are some kids who go like completely like, well, like way over the top. You know, like parents will get them into like those, you know, Saturday classes and whatnot. So, you know, like I know the competition for those schools is very intense. But that's good. You want to be in that environment, I guess. Like, you know, there is a place in the world for people who have that insane work ethic. There's a payday for that. So, but either way, Legend, good luck when you do take it. I don't want to just like blindly say like, oh yeah, you're ready, like for sure, like without knowing what you're, you know, how you're doing as a student. But I could tell you if you are doing well, like believe in yourself. Yes, what's up? Got a question. So go ahead. So while you're, oh, let's see. So yeah, no, some people will practice like, but look, 3 years of forced practice doesn't necessarily like guarantee your spot either. I would say like your foundation makes all the difference. Like if you're pacing yourself, like you don't have to work like every minute of the day to make it. You know, like that's like a big misconception. Like you do have to work hard, but you also have to throw breaks in the middle and like not stress out too much. You know, like there's I call it like the law of diminishing returns. Like at some point I treat it almost as like a logistic function. Like you're starting here and like, yeah, I'm practicing. And usually around here in calculus, we call that the point of inflection. Like your rate of growth. So this is like, I guess your like time. And this is like your output or competence. Okay, so competence. Hope I'm spelling it right. All right. So this is your competence. I mean, don't get me wrong. Like there's no, I guess there's a true like somewhat limit on how much you could learn on a particular subject matter. Let's say like this is like the perfect score. Okay, so like this is like the point of diminishing returns. So if you're studying for a test and like you hit this point, like, yeah, if you keep going, like you're going to improve, but there's a point where like it starts to cap off. And like usually around here, like you should like kind of think about stopping. Like stop here. The problem is like people go here and they're like, oh, I got to do like this much more. And it's like, yeah, but like you didn't realize it, but you were there already. And like use this time to like just like relax, you know, test, and then you stop and take a 2-year break and then show up and take the test cold. Like that's no good. So like you might be like in this section here. How could you fight hard? Like how do I fight hard problems? How do you tackle them? So yeah, really good question. The hardest questions, to be honest, it's more like I use the analogy of like you have like a body of water, and so there's a water, and I don't know, like you're like almost like trying to find like an alligator or something or some sea creature. So like here you are, and like you try something, like you throw a rock in, or you throw something in, and it creates like like the ripple effect. And then like you're like you hear like, oh, you hear something over here, and it's like, oh wait, I should focus on this. So then like you try something in this direction now, and you like you land a little closer, and the problem like really gives you some idea, and it's like, oh, all right. And then now you're in that neighborhood and you're solving what needs to be. And it's like almost like a, I attribute it also to like kind of like a mindset in chess, because I do play a decent amount of chess too. Like I'm not a master, but I'm like fairly like good at chess. My max rating was, if anyone plays chess, was like 1900ish. Right now I'm in like the like 1840s on chess.com. But it's like you explore something, you're like, no, not that, and then you're like, oh wait, it's somewhere in this neighborhood, and you just stick with it. But like the key is like some people like they try something, and like it hits a dead end. They're like, oh, I don't know what to do, and it might just be lack of knowledge. Like you may just not have the tools needed to do that question. Like it might just be out of your range because you have to like learn the stuff first. Like if you're in algebra or geometry and I throw you a calculus BC question, you're gonna be like, I have no idea what to do. And I'm like, yeah, you didn't learn it yet. But like if you've learned the stuff and it's just like stumping you, the key is like you got to stick with it, but you got to like change your perspective on something. You got to like, oh, this one missed, but I threw it here, and I'm like, ooh, this is leading me to something. So then you like explore this more. So you just develop like that maturity of like knowing like when something is a dead end and when something like you should keep going in that direction. Um, but the more you engage with questions like that, so at Fortnite, like the more you do hard questions, you'll just get better and better at doing those questions, and everything less than will just be so easy by default. So yeah. All right, so that is. I'm gonna keep rolling here. I do appreciate like I do like going on these tangents. I love when people write in the chat and giving me something to talk about. But I will continue these questions here to get to the end. So if 100 individuals will attend the museum, what is the best estimate? So remember, there's 1,750 kids out of 5,000 total for last year's attendance. So this will tell you kind of like the proportion or the ratio of how many people show up that are kids. So we multiply that by the total amount of people showing up to the museum next week. And then here I would just cross off the common zeros. And now we've got 1,750 over 50. And here I would cross off these common zeros. And this is 175 divided by 5. And that's 5 goes into 17 3 times, remainder 2. 5 goes into 25 5 times, so 35 I'm going to go with. So let me just see. What score do you think is all right for a practice time for someone by now before the test? You know what, to be honest, Legend, I'm only doing this because Fortnite put out that challenge of like, hey, you should do an SHSAT. I really am like brand new to SHSAT. I teach high school, so I never actually prepared anybody for the SHSAT. I might have tutored like one kid like 12 years ago on this, but like very briefly. So I don't even know what the scoring is for this test, to be honest. Like I mean, if this is well received, I kind of just go in the direction of what people really want to see on YouTube. If like there's a really big following for SHSAT stuff, like I'll do more of this for sure. But Fortnite, yeah, thank you. I guess yeah, I have to like become educated on the scoring and stuff. I have no problem admitting when I don't know something. So the math I know, but the other stuff like no. Oh, but see, look, probability. Like I never taught probability really in high school like that much. So this will be interesting. I'm gonna be out of my comfort zone. I haven't done probability in a while. So a teacher will randomly select 3 students to be on a school committee. Why can't I underline? Here we go. That's a little better. Let's make it perfect. All right. That's much better. So a teacher will randomly select 3 students to be on a school committee. He will choose either a student from classroom A or a student from classroom B with each selection. The tree diagram shows the selection of possibilities. Okay, what is the probability that the teacher will select 2 students from classroom A and 1 student from classroom B in any order. Okay, so we need like basically like an A-B situation, but the order doesn't matter. So this one, there's 8 possibilities total, because like just know, and 1, 2, 3, 4, 5, yeah. Like your options here, it's like, all right, there's 2 options, like A or B. 2 options, A or B. 2 options, A or B, and multiply them, that's 8 options total. So here, I'm kind of like cheating and using like different math. And watch me mess this up though. So we just need to count how many AABs are there. So there's like AAB. So far, you see like this is 1. So that's 1. ABA is another one. That's 2 A's and a B. And then, yeah, ABB is no good. And 3 A's is no good. So now we go this route. And we need 2 A's and a B. There's only one way that could happen here. So let me go in a different color here. So if we get a B first, then we need 2 A's. Okay, like that's the only way this will work. So you see that's 3 out of the 8 total. Just to show why the others are no good, like BBA is no good, that's 2 B's. BAB is no good, that's 2 B's. BBB is 3 B's, that's no good. All right, so we need 2 A's and a B. So that's 3 strings. So that's like, and I'll do them in different colors. So you see like AAB, that's 1. ABA is 2. And then B, so BAA is the third one. All right, cool. Later on, like high school math, you could use a trick. So, what's it called? It's like 3 combination 2. Like if you're making 3 selections and you want 2 of them to be A, like there's 3 ways that could happen. Okay, so but this is not like, yeah, so that's why I'm like, oh, 3 out of the 8 total is like the shortcut I'm doing in my head. But if we use this diagram here, the tree diagram, then you're just looking for how many different strings. So it's AAB, it was ABA, and then it was BAA. Those are the possibilities here for having 2 A's and a B. Okay, so cool. A bag contains 15 marbles, 11 blue, 4 red. Okay, so we got 11 blue and 4 red. Here we go. Sarah picks 1 marble randomly, returns it to the bag, and then randomly picks 1 marble again. What is the probability that she picks a red marble both times? Okay, so a red marble, there's a 4 out of 15 chance, but she returns it to the bag. Okay, so Sarah picks 1 marble randomly. The probability of getting red is 4 out of the 15. But then what's the probability that she picks the red marble both times? Well, then you have to do times another 4 out of 15. So 4 times 4 is 16. 15 times 15 is 225. So 16 out of 225. Don't add them. All right, we wouldn't add here. We multiply. Okay, this is like compound probability. I think that's the word, compound probability. I don't know. I'm rusty. I haven't done like the middle school math in a while. There's one class I never taught at high school was Algebra 2 for the regions. That's like the one like class I haven't taught AP stats either. But yeah, that's a class that I never got around to teaching. Oh, you would add if it's like an or situation. Like if I was like, all right, like red, green, blue, if it was like, all right, there's 3 of these, 4 of these, 5 of these, and it's like, what's the probability of like red or green? Then you're doing like 3 plus 4 out of 3 plus 4 plus 5. Okay, so, yeah, that's the, or you could even say here, it's like the probability of red, let's see, that's 12. So that's like 3 out of 12 plus 4 out of 12, which is still equal to 3 plus 4 or 7 out of 12. So that's when you add and stuff. All right. Anita is assigned to report on 1 topic in each of the, let me just check the time here, how much. All right, we're closing in on the 2-hour mark. I think I said 114 questions, right? So I'm all right, making decent progress here. Anita is assigned to report on one topic in each of the 4 subjects shown in the table above. How many different sets of 4 reports are possible according to the choices available to her? All right, so she has to report on one topic in each. So just know here, how many options are there? There's 1, 2, 3, 4, 5. So there's 5 topics in report 1. There's 1, 2, 3 options for 2. There's only 1 option for 3. And there's 1, 2 options for topic 4. I'm sorry. Let's start that over. There are 5 topics for report 1. There are 3 topics for report 2. There's only 1 topic to choose from for report 3. And there are 2 topics to choose from for report number 4. So now let's think about the question here. How many different sets of 4 reports are available according to the choices available to her? Okay, remember, she has to get to report on one topic in each of the 4 subjects. So someone might do 5 plus 3 plus 1 plus 2, which is not an answer choice. All right, that's cool. That was nice of them. So here, report number 1, there's 5 options. So this is the multiplication principle. Times 3 topics for English, only 1 topic for math, only 1 topic for science and 2 for math. So this is going to give us 15 times 2 is 30. So 30 options here. You could make a tree diagram, but that's going to be a nightmare. It's like, you're Kenya, Thailand, Chile. And then from here, it's like, all right, Robert Frost, Hughes, this is just going to be messy. That's why just knowing how to multiply it across is way easier. 102, a deck of 52 playing cards contains... at least I know how to play cards, so that helps, having a background in playing cards. If you don't know about playing cards, these questions are a little more annoying. That happens, if it's a cultural gap, if you come from a different country and playing cards are just not a thing. That's where the students from the United States have an advantage. So a deck of 52 playing cards contains 13 hearts. Sarah has 12 cards from this deck in her hand, 3 of which are hearts. The other cards remain in the deck. What is the probability that a card drawn at random from the remainder of the deck will be a heart? Okay, so let's think about this. So 52 cards, there's 13 hearts. Yeah, and just in case you don't know, there's 13 hearts. There's 13... I'm going to try to draw these now. So there's hearts, clubs, spades, and diamonds. So 13 clubs. I guess the other ones don't matter, but there's 13 hearts. All right, and now here, Sarah took 12 cards from the deck. So that means there's 40 left. Okay, so there's 40 left in the pile. And now, what we know here, she has 12 cards in the deck. 3 of them are hearts. Okay, so if there's 13 hearts total, there's 10. So this is how many hearts left. Okay, and this is the total left. What is the probability that a card drawn at random from the remainder of the deck will be a heart? So there are 10 hearts left out of the 40 total that are left. So that would be 1/4, choice F. Okay, so you got to subtract twice and then divide. Okay, so she took 12 cards away, so there's 40 left, but she took 3 of the 13 hearts out. So there's 10 hearts left, but there's 40 total left. So divide. All right, the table shows the probability of randomly picking each flavor of candy from a bowl. Butterscotch, lemon, maple, strawberry. Which flavor is most likely to be randomly picked? So the one with the highest probability, butterscotch? This seems too easy. Anytime a question is too easy on a test like this, especially at 103, I'm like, wait a minute. But lemon shows the probability of randomly picking each flavor of candy from a bowl. So the highest probability would be the one that's most likely to be randomly picked, I would hope. If I'm stepping in a bear trap right now, I'm going to feel bad. But I'm leaning towards this one. Yeah, butterscotch. That's kind of cruel. When they put something that's this easy, it's like, wait, are you really doing this to me right now? Are you sure you're not messing with me? So test psychology is a really delicate thing. I really don't like want to get too many wrong here. I hope I didn't get any wrong. If I got something wrong, then I'm like, oh no. But remember, this is I'm taking this cold to like model like my learning process too. Like I said, if I take a million practice tests, like I'm going to get questions wrong. I'm not like like a superhero. But all right, moving on. This formula can be used to determine P, the number of pages. So I'm going to label pages that will be in a book that contains W words with an average of R. So this is like words per page. And F extra pages in the front. So this is the extra. I might not have needed to do this, but whatever. If the formula is solved for W, oh yeah, I didn't need to do this. So basically take this and solve for W. So I probably should have just read all the way through and then read it a second time. So basically, like if this formula is solved for W, it can be used to find the number of words in a book with P pages. All right, so just solve for W. That's what they want us to do. So that's what we want. So I would start by doing minus F on both sides. So that video I made, the 100 equations, like this comes in handy. So we have P minus F equals 1 over R times W now. But now, you see how it's 1 over R times? If I want to get rid of that R, I could just multiply both sides by R. But I have to put this side in parentheses. So now, what we have is R times 1 over R. This cancels. And we have W equals R times P minus F. So, choice E. Not bad. Yeah, the questions that are like, this is like unnecessary words. This is like, here's an equation, solve it for W. Like, all right. A lot of fluff. All right, we're getting there. A shipment contains 170 small boxes of medical supplies. So small, 170. In a random sample of 20 of these boxes, 8 have damage and the others are undamaged. Okay, so sample. So 8 damaged out of like 20 boxes. So like 8 damaged boxes like out of 20 boxes. Okay, based on this sample, what is the best prediction of the number of undamaged boxes in the shipment? Not, wow, so double whammy here. What is the best prediction of the number of undamaged boxes in the shipment, not including, so they were nice to put that in bold, the boxes in the random sample. Okay, well, there was 170 small boxes, but you see what they did? They just took away 20 of them. So the new total, like this is our new total. But 8 out of 20 is, the ratio we have to work with here. So for the 20 boxes sampled, 8 of them are damaged. So we're basically doing 150 times 8 out of 20. But this will tell us how many are damaged. Okay, so how many are damaged? So here I would go like this. Cross off the 0. And now 8 divided by 2 is 4. And 15 times 4 is 60. So 60 are damaged out of the 150 remaining. However, they said, what is the best prediction of the number of undamaged boxes? So if there was 150 left in the new total and 60 are damaged, you subtract here, and this is going to give you 90. Oof, that's mean. Yeah, that's really mean. But watch this. Like, if you had said, like, oh, 8 are damaged, 12 are good, and you did 90 plus 12, like, you just considered all the boxes. You didn't read that part carefully. Like, 102, like, this is LOL. Be careful. All right. Yeah, this multiple choice is not necessarily easier. It's just, like, they give you more traps. You got to die. Like, so this is very trappy, this test. Yikes. All right. 106. So what do we have here? In basketball, a player can earn 1 point for making a free throw and 2 points for making another basket. Marcus makes a mean of 8 free throws per game, and he scores a total of at least 25 points per game. The inequality below shows this relationship where B represents the number of 2-point baskets Marcus makes. All right, so they set it up for us. That was nice. What is the number of 2-point baskets Marcus needs to make if he wants to score at least his minimum total points for a game and make his mean number of free throws? Are we just solving this inequality? Is that like really what's happening here? I'm just trying to make sure. So this is fine. This is fine. I'm just like scanning for anything funny here. Well, I'm just going to start by solving here. So when you're trying to like, and then I'll think about it. So he wants to make at least 25 points. So he needs to make at least 25. So 25 or greater. So this, if we subtract, is 17. And then divide by 2. And 17 divided by 2 is 8.5. Is 8.5. So think about this very carefully. What is the number of 2-point baskets Marcus needs to make if he wants to score at least his minimum total points for a game and his mean number of free throws? Well, for this one, we're going to have to round this up to 9 because you can't make half a basket. So F is jumping out at me right away, like that he needs to make at least 9. And you could even see if you did 2 times 9, that's 18 plus 8. And that's 25. So 26 is greater than 25. So that would be it. If he makes less than 8, that's no good. Less than or equal to 8. Because if he only makes 8, then you're going to have... Oh, wait a minute. 6. Oh, yeah. If you did 8, so if B were equal to 8 or anything less, then you're going to have 16 plus 8 is greater than or equal to 25, which is not true. 24 greater than or equal to 25 is not true. All right. So if he wants... So what is the number of 2-point baskets he must make? So the problem with this one is it's like not forgiving enough. And then B less than or equal to 25. Like if B was equal to 0, that's fine. But if he makes no baskets and just free throws, then he gets 8 points, which is not enough. So that's why this one's no good, because B equals 0 would satisfy this. But this one, once again, like if he makes 10 baskets, 10 is not greater than or equal to 16, but 10 would be fine. He would have 28 points, which is more than 25. So the second choice here is the best option, or is our answer. So it was one of those rounding situations. Let's see, how many more? I think 114, right, is the cutoff. Hang on 1 second. Yeah. Sorry, my wife had to ask me something, and just making sure it was nothing too urgent. All right, everything is all good though. Back to the test here. So question 107. Nadia paid $1 to mail a letter. So, okay, $1 to mail a letter. The cost to mail a letter is 55 cents for the first ounce of weight plus 15 cents for each additional ounce. What is the weight in ounces of the letter that Nadia mailed? Okay, so the first ounce is 55 cents. So the first thing I would do is I would take the dollar and I would subtract 55 cents. So there's 45 cents left. Okay, but this was for 1 ounce. But remember, each additional ounce is 15 cents. So if we take the remaining amount of money and divide it by 15 cents, see, this is the same thing as just doing 45 over 15. If you move the decimal twice for both of those, it's this. So that would be 3 ounces remaining. So that's 4 ounces in total. All right, and once again, if we break this down, the first ounce is, so 1 ounce is 55 cents, which I'll just write in dollars. Why am I writing it like this? So that's 0.55. And then the next 3 ounces are 15 cents each, which is 45 cents. And that makes $1. Okay, so this choice is good. 108, the cost, the number of oranges and the cost. The table shows the cost of oranges. What is the unit rate for the cost per orange? So that's how many for 1. So take any one of these and just divide, but I would take the smaller number. So $1.80 for 4 oranges will tell you how many dollars it is per orange. So just do, I would do 180 over 4 on the side. 4 goes into 18 4 times, remainder 2, and then 5 times, so 45 cents. So it is 45 cents per orange. That is the unit rate. Remember, for the unit rate means like for 1 orange. So if we divide the top and bottom by 4, like this is telling us how much it is for 1 orange, 45 cents. All right. 109, a softball player bought bottles of water for her team to have it practice. Okay. So softball player bought bottles of water for her team to have it practice. The total number of bottles she bought, B, is proportional to N, the number of players at practice. Okay, let me just think about this. Which equation represents the relationship between B and N? And the constant of proportionality is P. All right, so Y equals KX says Y is directly, directly proportional to X. And the constant here is the constant of, like K is the constant of proportionality. So this is just the formula that it helps to know and makes this question like much more doable. So now I'm going to, I guess the only one that's in that form is A, but I want to double check that A is it. So let's see. A softball player bought bottles of water for her team. The total number of bottles is B. So B is bottles. Proportional to N is, so B is bottles. This is number of players. And which equation represents the relationship between B and N? The constant of proportionality is P. So P is our constant of proportionality. So you see here the phrase, let's see, the total number of bottles. So B is directly proportional. So it's B equals the number of players N, and P is the constant of proportionality. So B equals P, and A is definitely it. All right. I just take my time on questions like this because they're easy to get right, but they're also very easy to get wrong. So the easy questions, don't like just rush through them and then you make a silly mistake and it's like, oh no. And I still got to go back and do that question 60 from the beginning. I didn't forget about you, 60. Saving the evil one for last. It's annoying. Like, that's a weird strategy to open the test with something like just kind of like cruel. All right. Malik earns $10 per hour at his job. So Malik, you're making $10 per hour. He wants to change to a job that will pay $12 per hour. So he wants, $12 per hour. What will be the percent increase in Malik's hourly pay if he makes this job change? Oh, okay. So the percent change, I just know it's 20%. How do I make this nice? I guess new minus old over old. That's what I'm thinking. So the new rate is $12 per hour minus the old rate is 10 divided by 10, which tells us here, like if you think about it logically, he's going to make $2 more an hour, but relative to how much he was making, that's that's like the new part over like the old, like the whole amount he was making. So percent, I always think like part over whole. So 2 over 10 as a percent is the same thing as 20 out of 100, which is 20%. So choice F, or the second choice. All right, so we got 2 more pages. A rain gauge shows that 10 centimeters of rain fell yesterday. If 1 inch is equal to, all right, so here we go. 1 inch equals 2.5 centimeters. About how many inches of rain fell yesterday? Okay, so 10 centimeters fell yesterday. So 1 inch over 2.5 centimeters equals 10 centimeters and then X inches. So for this, if you just know to get from here to here, it's like times 4. Then if you do this times 4, 1 times 4 is 4. So I just know it's going to be this. Otherwise, you would just do 2.5 times X equals 1 times 10 is 10, and then divide by 2.5. Either way, you're going to get X equals 4. All right, so 4 inches of rain. Choice C. All right, we're closing in. The height of a plant in millimeters is proportional. Oh, here we go again. Do we get letters? the height, I'm going to call h, is proportional to the number of days. I'll put x. So is equal to k times x. How about I call it y and x? Why am I using h? I guess h for height. Alliteration is nice, but height is y, days is x. So y equals kx. So let's see. So the plant has grown 20 millimeters in 8 days. So that's, remember, x is days. So x is days, y is millimeters. So 20 millimeters in 8 days. So that's 8 times k is our constant of proportionality. So to solve for it, we just divide by 8. So k equals 20 over 8. And just, you could reduce this, divide the top and bottom by 4, and you'll get 5 over 2, which is the same thing as 2.5. Okay, the height is directly proportional to the number. So it's y equals kx. It's that same formula all over again. So 2.5. All right. Oh, in millimeters per day. So that's, yeah, good to know. The unit here, so I think of like the xy axis, just to add to this. So y is millimeters and x is days. So if we see here, like, oh, 20 millimeters, like, so it's like 8 and 20 puts us here. So you could see like it's kind of like the slope. It is the slope of the line here. So the 20 over 8, you see how it's like millimeters per day. A good answer, but a wrong one is this. That would be like someone who goes like, oh, 8 over 20. But the problem with that is 8 represents days and 20 represents millimeters. So you see that would be, what is the constant of proportionality in days per millimeter? And in that, they would say the number of days is proportional to the height of the plant. So the order of things matters. Oh, I'm glad at Fortnite. I appreciate that, that you're picking some stuff up here. I'll teach, as much as I can. So last 2 questions here. Wow, we made it. It's always nice when you get to the last page. It's like, all right. So which table shows a proportional relationship? So that means like the ratio of like x and y, like this ratio, like the ratio does not change. Okay, or yeah, I guess that's just one way of saying it. So let's see, are any of them? I don't think this one looks good. This one doesn't look good because this one, it's like plus 12 and then plus 4, and this is plus 4 plus 4. Like the x's and y's have to be going up by the same amount. This one looks kind of good. See, this is plus 1.5 or 3 over 2, and this is plus 1.5. See, this is the same thing as 1.5, and 1.5 plus 1.5 is 3. So this is already looking good, but we'll see why the others are no good. Because I would want to make sure the others are no good before I could confidently say that's our answer. So this, just know 7 over 2 is 3.5. So, but we're starting at 1. So if I'm going from 0, 1, that already doesn't look good because we're not starting at 0, 0. But you see that's plus 2.5. Oh, okay. The proportional relationship, remember, is like the y equals kx. It has to go through 0, 0. Okay, so that's an important idea. It has to go through 0, 0. So I would say, like, yeah, these answer choices right away are out. This is kind of like that graph question we had where we look for the one that went through the origin. It's like the same question. Like, even though this one does go through 0, 0, you see how it goes up 12, but then, like, this is, like not a constant rate of change. Okay, so that's why this one's out. So A is definitely good. All right, cool. Last question. Terry wants to pour cement around the edge of the circular patio in her backyard. All right, so the patio is circular, and she's pouring, or he is pouring, oh yeah, her. She's pouring cement around the edge of the patio. The patio has a radius of 5 feet. Okay, so 5 foot is the radius. Oh, use 3.14 for pi. That would have been really helpful if they told me that earlier. Terry wants to pour cement around the edge of the circular patio. Edge of a circle? That sounds weird. But yeah, the perimeter would be nice also to say. the patio has a radius of 5 feet. What is the distance in feet around the edge of the patio? Well, circumference is pi times diameter, or you could say 2 pi r. Okay, so if the radius is 5 feet, the diameter is 10 feet. So the pouring cement around the edge, no sneak attacks here. All right, so what's the distance around? So you're just going to do the circumference is pi times, 10 feet. They don't put units, though. They're saying the distance in feet. So I don't have to write this. And they're saying, hey, use 3.14. So when we multiply by 10, at least this time they were polite. That's 31.4, choice F. All right, so that is the last of the questions. I will check the answers. The answers are there, but I will open a separate PDF so it's like I don't have to keep scrolling. But I have to do question 60. All right, remember, 60 I left blank. Oh, 61 I left blank. All right, this evil question. Let's get this. All right, I'm motivated now. All right, now I'm warmed up. But hopefully that warmed up and burned out is also like a fine line. So a grocery store sells 1 gallon containers of milk. Okay, so milk. Let's write that again. You are 1 gallon, $3.99. Cool. The store also sells orange juice in 6 packs, 5.5 fluid ounces, in a 6-pack of 5.5 fluid ounce bottles for this. So I'm going to do that first. 5.5 times 6. 30, carry the 3. 33, wait, I just make sure I added that, right? 30, carry the 3. So that means it's 33. So orange juice, I'll put OJ, is 33 ounces. And that will be $1.79. To the nearest dollar. Okay, so we got to round to the nearest dollar. How much more would a gallon of orange juice cost than a gallon of milk? So here, the idea, let me just see. It's kind of like what I was saying before, but 1 gallon is 4 quarts. 1 quart is 2 pints. And 1 pint is 2 cups. Okay, is 2 cups. And just know 1 cup is 8 fluid ounces. So we got to play this game now of, okay, like 1 gallon is 4 quarts, but that's 8 pints because I just replaced quart with 2 pints and 4 times 2 is 8. So I have 2 pints. Remember, 1 pint is 2 cups, so that's 16 cups. And a cup is 8 ounces, so let me do that on the side here. 16 times 8. This might be excessive. I'm going to look at the answer key after and see like what's the nicest way. But 16 cups is 128 ounces. Okay. Now, are they asking us to approximating doesn't help. Let me just see something. 66 times 2. I already know the answer to this. 132, which is almost this. But I feel like almost is not going to save us. Yeah, it's not. It's got to be a little more. I want it to be precise. All right. So now that we have this information here, what I'm getting out of this is I could turn, let me see, 33 ounces over X gallons is equal to 128 ounces over, let me just see. I want to turn ounces to gallons, but then even this, it's like, I'm just trying to think of this the nicest way, considering we don't have a calculator. Because like I obviously if I had a calculator, like it would be done like very quickly. But remember, it's 33 ounces for $1.79. We got to find out how much is it for. I guess I could just do that proportion I was going to do before to see how much am I paying for 128. Okay, so let me just do it the painful way. All right. So 128 ounces is how much? So here we've got 33 over 128 equals $1.79 over X. Okay, so 33 ounces for every 128 is going to be equal to whatever this ratio is here. All right, I could have also done 33 over 179 equals 128 over x. Like either way, we're getting the same. So I get 33x equals. And now let me suffer here. So 72, carry the 7. So 56 plus 7 is 63, carry the 6, and this is 14. And then 18, carry the 1. 15, because I'm going to have 14 plus 1 is 15, carry the 1. 18 plus 1 is 19. And then double 0 here. And I'm going to have 9, 7, 9. So this is 2, 11, carry the 1. 19, carry the 1. 18, carry the 1. And then 12. Why does this look ridiculous? Yeah, I did the same thing I did before. I got to go slow with it. Yeah, 3 by 3 multiplication. You got to be careful. All right, we're going to get this. Okay. 179 times 128. Take your time. 72. Carry the 7. 56 plus 7 is 63. Carry the 6. 8 times 1 plus 6 is 14. Placeholder. Cross these out. 2 times 9 is 18. Carry the 1. 2 times 7 plus 1 is 15. Carry the 1. 2 times 1 plus 2 is 3. Placeholder. 2 placeholders, because now we're coming from the hundreds. 1 times 9 is 9. 1 times 7. And 1 times 1. 8. I'm sorry, whatever, 8. 2 plus 0 is 2. 3 plus 8 is 11. We carry the 1. That's going to give us 19. We carry the 1. And now we've got 10 plus 2 is 12. Carry the 1. So this, if you think about, we're doing $1.79 times 128. That's going to give us 229.12. Okay. So now I will erase this stuff over here. All right. Hopefully they would give us scrap paper or something. I'd have space to write stuff out. Okay, so now I'm dividing this by 33. Wish me luck. So now 229.12 divided by 33. So it's going to go in here 9, not 8, 7 I'm thinking. So 33 times 7 is 21, carry the 2. And this is, ooh, 2, wow, it just misses. 33 times 7. 21, carry the 2. 231. So it's got to be 6. All right. 33 times 6, on the other hand, 18 carry the 1 is 198. So now I can subtract 198. 1. Can't do this. I got to borrow. So 31. Decimal goes here. We bring this down. Okay. So we bring this down. 311. It's going to go in 9. Seems like 9 times should be good. Yeah, so let's do 33 times 9. There's definitely an easier way, but whatever. Minus 297. 4. 14. Okay. Oh, yeah, 9. I forgot to write the 9 here. So 9 times this was 297. Now I bring down the 2. And then 33 goes into 142. Is it 4 times? Let's see. 12, carry the 1, 12. Oh, okay. So it's going to go in 4 times. And 4 times 33 is 132. So this is going to give us a 10. I could put another 0 here and bring this down. And now how many times does it go into 100? 3 times. So that would be 99. Remainder 1. Okay, so we'll say 6.9. So that'll be, let's see here, 128 ounces or a gallon is $6.94. If I get this wrong, I'm going to be devastated. So to the nearest dollar, how much more would a gallon of OJ cost than a gallon of milk? So now I just subtract these two. $6.94 minus $3.99. So $3 more. So to the nearest dollar, $3, please. All right, time to check the answers. All right, I'm nervous. I hope if I got 61 wrong, I'm gonna be devastated. That was, but whatever. You live and learn. All right, 58. Here we go. 58 is 1.1. Where am I? 1.18. So we are good on 58. 59 is 1.5. 60 is 12. 61 is 3. Yes. Probably a much easier way. I probably could have just rounded to the nearest dollar. Means I probably should have just rounded stuff. I don't know what I was thinking. Sorry about that. But whatever. 62 is 15, which I circled. Yes. Business. Finally, multiple choice. 63 is D. 64 is F. 65 is B. If I get one wrong, then I have to explain why it's not right. E, F, G, H. 67 is choice C. 68. Oh, that was just base times height, right? Is E. 68 is good. 69, choice D, yes. 70, choice H, E, F, G, H. Oh, that was the sneaky one. Dodge that bear trap. 71 is C. Yes. 72 is E. 73 is choice C. 74 is choice G. All right, so we're doing all right so far. I don't want to jinx it. 75 is C. 76 is G. 77 is B. 78. Are you H? You are. All right. 79. Choice B. 80. Are you choice F? Oh, I didn't do 81. All right, I'm not looking. Okay. I swear I didn't see. All right, so I skipped one. All right, so I lose a point because I just missed one, but whatever. Move the decimal twice. 1296. So I'm doing 12.96 over this. Whoops. Over 0.08. Just move the decimal twice for both of these. Okay, and then 8 goes into 12 once with the remainder of 4. 8 goes into 49 6 times. That's 48 with the remainder of 1. 162. So 81, your choice C. All right, cool. I mean, that was division, so I'm hoping that doesn't ruin my credit here. 82 is choice E. 83 is choice D. Awesome. 84, your choice G. 85, choice D. This one was weird. The whole revenue minus cost idea. 86, did I? Yeah, we got 85. 86 is F. 87 is A. 88 is F. 89 is C. 90 is, should be H. Let's see, is it H? Yes, is H. 91, choice C. 92 is choice F. Very nice. 93 is choice D. 94 is choice H. 95 is choice C. All right. I really don't want to lose here. 96 is E. Oh, we're on such a streak. 97 is A. 98 is G. 99 is choice B. 100 is choice E. All right, so we got 14 more to go. Here we go. 101 is C. 102 is F. 103, you wacky question, was A. All right, cool. 104 is choice E. 105 is choice C. That was the sneaky one. Yeah, the trap. All right, bear traps everywhere. 106 is choice F. Very nice. Yeah, E, F. Yeah, when they don't go A, B, C, D for each one, it's like I can't go as quickly. I got to really make sure. All right, 107 is D. 108, choice E. 109 is A. 110, I almost said 1010. 110 is F. 111 is C. 112 is F. Oh, here we go. Drum roll. 113 is A. And 114 is F. Wow. All right. I wasn't like expecting, like, oh, I'm definitely getting 100. So I'm happy I got the 100. 100%. So, yeah, that was, I enjoyed that. Something different. Getting out of my comfort zone. They don't give scrap paper either. Yeah. Fortnite. So I'm so smart. If I were to take 10 of these, I wouldn't get perfect scores on all of them. Like I would almost bet. It's practice. Remember, I already did K through 12, and then I was a math major. I've been teaching math for, 10 years. This will be my 11th year. Teaching AP Calculus also, so I'm in front of a lot of wacky stuff. So I have a lot of test-taking experience dealing with crazy tests. But look, if I took every Regents, every June, August, and January, I'm not getting 100 every time. I'd get a few hundreds maybe. But it's all about practice, but reflect also. Like, the more you practice, the better you get at practicing too. You come up with better methods for studying and taking tests. So that is that. But all right, I am going to cap it. I promise you, getting a 93 or whatever it was on your algebra Regents as an 8th grader, you are on a great path. All right, you are on your way. Just keep doing what you're doing. And I would say you're already really good at math, but it's more to it than just like, oh, I got the perfect, like, oh, look, a perfect score. Like, yeah, I'm satisfied. Like, yeah, I got the 100. But it's more about like just trying to level up, trying to expand the stuff that you're able to do. In my case now, it's more about like giving back and like teaching. Like I'm not necessary. I'm at this stage of my life, like I've resigned to, like, I'm not going for like the PhD in math or whatnot. Like I'll still look at interesting and challenging math questions, but I'm more interested now in the teaching side of things and the YouTube side of things. That's the direction that I was pulled and whatnot. But like chess I play like for like that mental stimulation and whatnot. But yeah, that's like kind of I guess where I'm at now. But just keep doing what you're doing. You're on a great path, and I'm sure it's gonna take you somewhere nice. So all right, that is the end of the stream. Thank you for stopping by. Thank you for watching the replay. And yeah, let me know in the comment section below if there's anything specific you'd like me to cover in the upcoming weeks. But otherwise, thank you